In this question, I'm asking you to propose a synthesis of this molecule here called 2-methoxy, 2-methylpropane. Don't worry that you do not know how to name that yet. We haven't talked about that in the book yet. And we're going to make this product by starting with these two starting materials. So we have methane here, and we have 2-methylpropane or isobutane, whatever you want to call it. What this means is that in this product, all of these carbons that are in this product must come from either of these starting materials. We can't have carbons coming from any other structures. All right, so those are the rules here. You can use any other reagents needed to make these transformations. All right, so in the last example, number 4, if you looked at that one already, I'm telling you, you need to do these backwards, okay? No matter how easy you think these are going from the starting material to the product, in the future, this is going to get more complicated. So as long as we get in the habit now of starting from the product and working our way backwards to the permitted starting materials, trust me, these questions will be much easier for you than anyone else who's trying to do these from the starting material to the product. All right? So as we go backwards in these, we're just going to keep asking ourselves the same questions. We're going to look at one thing at a time, and we're just going to ask ourselves, how can we make this, and what can we make this from? So we're going to try this one. We're going to do this one 2 different ways, because again, with synthesis questions, there usually is not one correct answer. There's multiple correct answers. There's many different ways to make things, and the more reactions you know, the more possible routes you can take. All right, so I'm going to redraw this product here. All right. And again, we're going to work our way backwards. So I'm going to draw a backwards arrow here, because what I'm saying is that we're trying to answer how we can make this structure from what can we make it from and what reagents can we use. All right. So I'm just looking at the functional group that's present here. It is an ether. And I'm just asking myself at this point in the book, how do we know how to make an ether? Well, we can do SN2 reactions using some sort of alkoxide ion, or we can do an SN1 reaction using not the alkoxide ion, but the alcohol itself. All right, so we could do this either way here. So what I'm going to do is I'm going to start by doing the SN1 reaction. So if I'm doing the SN1 reaction, and I know I can start with methane and isobutane, and I know that it's pretty clear that this portion came from the methane, and this portion must come from the isobutane. That kind of lets me know this is the new bond right here. This is definitely a new bond, right? So I'm just asking myself, how can I put this methoxy group on that tertiary carbon? Well, the only real way you know at this point in the book is you could have had a reagent like this that has a good leaving group on that central carbon, and I'm going to go ahead and put bromine there, and that's not a coincidence. I'm putting bromine there for a specific reason. I'm not using chlorine here, so I am thinking ahead a little bit, and I'll explain why. If I have that tertiary carbon with a good leaving group, I can react that with something like methanol. That leaving group, the bromine, it will leave. It will form a tertiary carbocation. The oxygen will then add to that and then be deprotonated, and that will form this structure here. So that would be an example of the SN1 reaction. All right, and then what I'm going to do is I'm going to have to come back and explain how I made these reagents. So in this moment, I'm focusing on this 2-bromo, 2-methylpropane. I'm just asking myself, how can I make this? And what can I make it from? Can I make it directly from the permitted starting material, isobutane? And the answer is yes. I can remove that tertiary hydrogen by doing a radical reaction using bromine and UV light. And that is why I chose bromine. Because remember, bromine is selective. Bromine will form will break the easiest carbon-hydrogen bond to break, and that'll form the tertiary radical. So remember, this thing will go through a tertiary radical intermediate. That means bromine will be very selective, and it'll end up on this tertiary carbon, which is exactly where I want it, because that's where I want the oxygen to add. I didn't use chlorine here because, yes, I will get chlorine in this position, but I will also get chlorine on all of those primary carbons, and that becomes very wasteful. So yes, chlorine will work, but it is not the best answer. So this gets us back to a permitted starting material, so we're done with that. Now I'm going to come back to this alcohol, methanol. Remember, I got to make this thing from methane. So I'm just asking myself, how can I make an alcohol? Well, you could do it via SN1, not in this case. You can also do it via SN2. But if I'm doing this via SN2, that means this must have had a good leaving group. So I'm going to randomly choose bromine here. I could have chose chlorine if I wanted to. In this case, it wouldn't matter. Then I got to think about, what did I make it with? What reagents did I use? Did I use water? No, water's not strong enough to go in there and kick out that bromine. But the conjugate base of water, hydroxide, is absolutely capable of attacking this carbon and kicking out this leaving group in an SN2 fashion. So I can use something like sodium hydroxide or potassium hydroxide in some sort of SN2 reaction. But now I have to explain, how did I get this structure here, bromomethane? Can I make that directly from methane? And you know you can. You can use bromine and UV light to do that radical reaction. And that is a permitted starting material. So this would be a good synthesis for how to make 2-methoxy, 2-methylpropane. And that is one possible route. I'm going to do another route here. So let me erase this. All right. So I'm going to do a little bit of a different route. In this one, we're going to do the last step differently here. So we're still going to end up forming this. We're still going to end up forming a new oxygen-carbon bond, but this time it's actually going to be. I'm going to draw this out here so we can kind of see this. In the last step, this is going to be our new bond. All right. So if this is our new bond, I'm just asking myself, how can I make this ether? We already did it via SN1. Now we're going to do it via SN2. So if this is the new bond, and the oxygen must have been the nucleophile here because that's the thing that has electrons to attack, that means that I must have had oxygen with a negative charge here. And it must have attacked this carbon here, which is the one carbon of the methyl group. And if it was going to attack that carbon must have had a good leaving group on it. So I'm just randomly choosing bromine there, but you could have chose iodine or chlorine. Iodine, probably not the good one to use because I haven't showed you how to put iodine on there from methane yet. Okay. All right, so we're going to have to explain how we made these things. So here, we just have the conjugate base of an alcohol. Well, we're just going to draw in the conjugate acid of that, which is the alcohol itself. So there's our alcohol, and we're just going to deprotonate it. We can do that with base, sodium hydroxide, NaH is another one. Sodium metal itself can just deprotonate that. Something is going to act as a base and remove that proton to form this alkoxide ion. Then we have to explain, how did we form this alcohol? Keeping in mind, we got to work our way back to isobutane. Well, how can we make alcohols? We know we can do them via SN2 or SN1 so far, but we could not have made this one via SN2. Why not? Because that would involve using a hydroxide ion, and it would have had to attack this carbon here, which is tertiary. We don't do SN2 on tertiary carbons. So it must have been an SN1 pathway here. So we probably had a structure like this, and I'm going to choose bromine there. And we must have used not hydroxide, but water, so that it waits around for the carbocation to form, and it goes via the SN1 mechanistic pathway. And then why did I put bromine here? Same reason as last time. We want this carbon to have the leaving group, so we want to maximize the leaving group ending up on this carbon here. So we want to use bromine and not chlorine. So we're going to use bromine and some sort of radical initiator like UV light. And that gets us back to a permitted starting material there. And then we're back up to this bromomethane. We know already from the last example, we can make that directly from methane by using bromine in an initiator like UV light, and that gets us back to our permitted starting material. So those would have been 2 ways at this point in the book that you can use to synthesize an ether from those permitted starting materials.